Welcome to Further Solutions Academy. Further Solutions Academy. Help us to share our video and subscribe to this channel. If you have not subscribed before, we have over 170 videos on it. You can help us to subscribe to it. Please help us. Okay, now just please help us to subscribe. Now, I'll be working on the De-moivre theorem on this video. If time permits me, I will try to show trigonometry function, trigonometry, hyperbolic, and logarithm of complex number. Now, let me start. Now, if we are talking about the De-moivre theorem, just to show some things with the help of trigonometry and with the help of mathematical induction, which is very, very important. If you don't know mathematical induction, you have to go back to our platform and learn mathematical induction. It's very important at this point. Now, if I'm talking about, in our previous video, I've shown polar form, exponential form, and normal form, which is and also show on the Cartesian plane, which is we call it Argand diagram, and which is repetition of the plane shape, and also we have shown the property of conjugate and other part of it. Now, let's move on to this part, which is very, very interesting and very, very nice. Now, let's start. It means if I'm talking about my z, you all know that x plus ij. Now, which I've told you that this is real part, this is imaginary part, which we have done that earlier. Now, this is real and imaginary. Now, and I also say that what if I have it this way, it means my z can also be equals to sin t and I cos t. Now, and also plus. Now, also I can as well write this as okay in the bracket of this. Now, since I know this, okay, I know this one, I can answer that what my z can be equals to r exponential, which is now polar form, which is this one is called exponential form. Now, this is exponential form. It means now given that z1 equals to r1 e I theta 1 and z2 r2 e I, this is I theta 2. Now, since I have it this way, it means my z1, z2, it will be equals to r2 e theta 1 dot e theta 2. Now, since I have it this way, with help of my indices, they are the same of base. It means I can say that my z1, z2, it will be equals to r1, r2, it will be e raised to power I bracket of 1 plus 2. Now, condition, if my z1 equals to z2, if my z1 equals to z2, it means I'll be having this of 2. Since they are equal, it will be equals to r squared and e I 2 theta. It means they are equal. If they are equal, they can be added up. Since I have it now, run to n term. Run this to n term. It means my z of n, it will be equals to, I'll be having r of n e I of n theta. It means my n is represented to here now. Now, which my r must be, it means my radius must be 1. My radius must be 1. Now, it means I can now write this as well as my z of n, it will be equals to, since I have it this way, it will be equals to r of n bracket of cos n theta plus I sine n theta. Now, now what am I having here? This is exponential form. This is a what? Polar form. Now, at this polar form, I can now run towards okay. It states, which is it states that now I want to state the for any real number n, which is now we can now prove by mathematical induction. Now, mathematical induction. How do I go for mathematical induction? It's a very simple part of mathematics that if you do not understand it, go and view it on our previous video. Now, it means if I should go on mathematical induction, my z equals to Rn cos n theta plus I sine n theta. Now, what I will do for n equals to 1. Now, since I know for my n equals to 1, it means my z of 1 equals to R1 bracket of cos theta plus I sine theta. That is when my n equals to 1. Now, it means it is true. It is true that n equals to 1. It is surely true that n is equals to 1. Now, assume that n equals to k. My assumption for n equals to k, it means I'll be having z raised to power k equals to r raised to power k and cos k theta plus I sine k theta. Now, at this point, I have nothing. Since it's true for 1, it will be true for 2, and also true for k. Then it is true. It is true. Okay, let's say assume, because I assume that is true. It means assume that it is true that my n equals to k. Now, I will now move on to the next one. I have to rub this part, please. I have to rub this part. Please take note of that. Now, I will move on to the next one, which I will be talking about. Okay, we have assumed for k. Assume. I will now assume for the next one. Assume. Okay, let me show n equals to k plus 1, because we have done this for n equals to k. Now, I'm now going to n equals to. It means what I'm having z k plus 1. Whenever I see n, it will represented by k plus 1. It will be equals to r raised to power k plus 1, which is that, and r raised to power k plus 1, and also which is I'll be having cos k plus 1 theta plus I sine k plus 1 theta. I'll close my bracket like this. Now, this is where work is. Now, at this point, I want to learn to think something. Now, if I should break down this, my zk plus 1 can also be written as z raised to power k and dot z raised to power 1. And I have my z raised to power k here. This is my z raised to power k, and z raised to power 1, I have it here. It means, like I can say that what? It means my zk dot, I'm just playing around with my indices, knowledge of indices, which I'll be having zk, which can be equals to, I will now move on by having okay, now I've assumed that my r equals to 1. If my r equals to 1, it means this can never change anything. I can neglect this my r, because since my r equals to 1, I can neglect that. I've said that earlier. It means I'll be talking about cos. It will not be cos. Now I'll be having cos k theta plus I sine k theta, and bracket of what's mine, which is going to be this cos theta plus sine theta. Now, by opening bracket, which is normal expansion in mathematics, which is in our elementary mathematics, I can now run to expansion. How do I expand this? It means I will cos k theta against what is here, plus I sine theta plus I sine k theta, bracket of cos. Sorry, I need to wipe up some part of this part. Sorry, please, I need to increase the board because I'll be consuming a lot of space now. Now, I'll be having cos this theta plus I sine theta. Now, if I'm to open bracket, it means dk dot equals to, I'll be having cos theta k cos theta only, plus, now this one will be I sine theta cos k theta, and plus I sine k theta cos theta, and plus I squared. Now I'll be having sine k theta sine theta. Now, since I have this, I need knowledge of trigonometry very, very well here now. This is very, very important to understand trigonometry very well. Since I have it this way, this my high will turn everything upside down, which it will turn this one to minus. Sorry, without going far, I can turn this to what? To minus. It means I'll be, because I square is always minus 1. I square is always equals to minus 1, which is, I've told you earlier, minus 1 multiplied by minus 1, which is I squared. I've told you earlier there. Now, which is also equals to minus 1. Now, I don't need to stress myself on that part because I want to look for space. My board is not very good. Anybody that wants to sponsor will need sponsor at this point. Now, so that I can have a larger classroom and other board. Now, I think this and this can play with themselves, and this can play with themselves. Now, z of k equals to, I will be having, which one should I have them? Okay, let me cos k theta and minus sine k theta sine theta, and this one will now be plus I into bracket of sine theta cos k theta plus sine k theta sine theta. Now, okay, it means already I have my what real part and my what imaginary part. That's what I'm trying to say. Now, with the help of my trick, which is, we call it a double angle, we all know that if I have recall that, wow, from our knowledge of trick, if I have cos a plus b, it will surely be equals to let me have minus like this. Let me go play around with minus. It will be cos a cos b minus will be sine a sine b, which is from our elementary mathematics. And also, if I have it sine a plus or minus b, it will be also be equals to, now if I have this way, this one will be equals to sine a cos b plus or minus, the sign will remain the same, sine b cos a. Now, that is what I'll be having. With the help of my trick, that is what I'm just working towards here. With the help of this, I can now do one or two things which it will help my situation. I can say that what my z k plus 1, which is same thing as what k dot k, dot z raised to power 1, which it will be equals to, with help of this trigonometry, I can now continue by having cos k theta plus theta and plus I sine k theta sine. This one will be minus. Okay, yes, okay, that is going to be sine k, which is going to be plus theta. Now, since I have it, let me manage this part of the board. Since I have it this way, I can now continue by having, which it will be zk plus 1, it will be equals to, I can now say that what, cos theta bracket, or let me do it this way, k plus 1 theta plus I, which is going to be what, sine k plus 1 theta. Now, which is, since I have it this way, my problem has solved, which is, it is true that my n equals to k plus 1. That is what we are trying to do when it comes to De-moivre's theorem. That's what we are trying to do when it comes to, okay, that is all about De-moivre's theorem. It means by achieving this De-moivre's theorem, you must be very, very smart in your trigonometry. You must also be very good in your mathematical induction. Please take note of that. You have all this in our platform which you can play around with. Now, let me quickly show one or two trigonometry, hyperbolic, and logarithm function, and some example also, if time permits. Okay, now, if I'm talking about trig, let me call it. I have to disconnect the movie story. I don't want to look at it. Now, let me talk about trigonometry. Hyperbolic, and log functions. Log of complex number. Okay. Now that's what I want to show from this part. It's a very simple part of mathematics, which is you need to understand. They are all simple. Just calm down. They are easy to learn. Now, and make sure when you are learning this type of mathematics, you must practice more. Don't assume you know. Okay, before our time goes